Today we are going to learn about insertion sort. So, what is sorting? We have to arrange the numbers in ascending or descending order. That is sorting. So, we have to arrange it as 1, 2, 3, 4, 5, 6, 7, 9. So, if we arrange this in ascending order, that is sorting. So, we'll see how insertion sort works. So, our current is 1 and current less than n current plus plus. So, a loop runs from this to this. From 4 to 1, one loop runs. Then the second loop runs backward. So compare is equal to current minus 1. So it runs from 5. So with the first loop, the current element is 4 and we will store it in a variable temp. This is our temp. We'll take the current element and store it here. While compare greater than or equal to 0, compare greater than temp. So we will compare this element and this element. So 5 is greater than 4. So EI of compare of is greater than 10. So now we will shift this one position up. So compare plus 1 equals to ARR of compare. So we were shifting this element here. Next, the compare is equal to compare minus 1. The compare was 0. Now it will become minus 1. Since compare is not greater than or equals to 0, it will go to the next step. This step. ARR of compare plus 1 equals to 10. So this element is shifted to this position. Then it goes to this and increments the current. So the current becomes 2. Now our current element is 9. It is stored in temp. We are comparing with the element 5. Current minus 1, which is 5. So 9 and 5 are compared. 5 is not greater than 9. So there is no change. So we shift back to the position. Next, our current element becomes 6. We will store it in the key and then compare 9 and 6. 9 is greater than 6, so shift 9 to one position up. Now 5 and 6 are compared. 5 is not greater than 6, so there is no change. So we will shift 6 back to this position. Now our current element becomes 2. We will store it as a temp. So 2 and 9 is compared. 9 is greater than 2, so we shift 9 to next position. See, compare plus 1 equals to ARR of compare, so we are shifting it here. Again 6 and 2 are compared, so ARR of compare is greater than temp. 6 is greater than 2, so shift 6 to the next position. 5 and 2 are compared. 5 is greater than 2. Error of compare greater than 10. Error of compare equals to compare. Compare plus 1 equals to error of compare. So we will shift this to the next position. Again 2 and 4 is compared. 4 is greater than 2, so shift it to the next position. So compare becomes less than 0. So we will shift 2 to this position. Our next element compare, now the current element becomes 3. We are shifting it to the key. 9 and 3 are compared, so shift 9 to next position. 6 and 3 are compared, shift 6 to the next position. 5 and 3 are compared, 5 is greater than 3, so shift 5 to the next position. 4 and 3 are compared, 4 is greater than 3, so shift 4 to the next position. 2 and 3 are compared, 2 is not greater than 3, so put 3 to this position. Now our current element becomes 7, so store it in the variable temp. 9 and 7 are compared. 9 is greater than 7, so shift 9 to next position. 6 and 7 are compared. 6 is not greater than 7, so shift 7 to the compare plus 1 position, that is this position. Now we will take the next element. Current element is 1. We'll store it in temp. Now 9 and 1 are compared. 9 is greater than 1. So shift 9 to the next position. Now 7 and 1 are compared. 7 is greater than 1. So shift 7 to the next position. 6 and 1 are compared. 6 is greater than 1. So shift 6 to the next position. 5 and 1 are compared. 5 is greater than 1. So shift 5 to next position. 4 and 1 are compared. 4 is greater than 1, so shift 4 to next position. 3 and 1 are compared. 3 is greater than 1, so shift 3 to the next position. 2 and 1 are compared. 2 is greater than 1, so shift 2 to next position. Now the compare becomes less than 0, so you will add it to the next position. So shift 1 to this position. Now the elements are sorted.